Okay, let's take a look at another method when working with equations. 4 is equal to 2 to the x. Well, we know the answer is 2, 2 squared is 4, but let's learn some methods. So a method we have is logging both sides. Very similar to delogging both sides, which we learned in the previous sections, but now log both sides. So I have this exponent, I can bring it down in front. So we have log 4 equals x log 2. Now I'm going to divide both sides by log 2 over log 2 over log 2. But again, remember in the future, all I have to do is cross it off and say where it goes. On the other side, on the bottom. So now I can perform change of base. Rule number 3 on your formula sheet. We walked through it in 8.3. So I have log base 2 4 equals x. Now what power do I have to raise 2 to equal 4? 2. So x equals 2. So let's take a look at an example where in the notes it's worked out perfectly. But I'm going to skip steps. So I'm going to skip logging both sides. I'm going to skip bringing the exponent down in front. I'm going to skip dividing. I'm going to skip change of base. I'm going to go straight to exponential form. So remember the, base of the exponent is the base of the logarithm. And remember, the exponent is the answer. And the 3 goes there. It's going to be a lot easier to go this direction, but we have to remember we can go this direction. Then, for example, we could type it into our calculator with math alpha math, and we could get our answer 0.6826. Lots of the times they'll just say turn into log form, or actually answer the question in a decimal. But this is an exact value for x. This is a rounded decimal. So just going into a little bit of steps before we log both sides. Let's say 3 equals 2 to the x minus 1. I want to make sure that I add 1 to both sides. 3 plus 1 is 4 equals 2 to the x. Now let's take a look at if I have a multiplication. So 8 is equal to 2 times 2 to the x. Well, I can divide both sides by 2, and 4 is equal to 2 to the x again. So making sure that we do all of our algebra before we log both sides. If I don't, and I still have that same question, 8 equals 2 times 2 to the x. Well, if I log both sides, on the right-hand side, I have a multiplication, so I have to separate it into an addition. Log 8 equals log 2 plus log 2 to the x. Then I could do a bunch more steps trying to solve for x, but remember, it's going to be easier to do your algebra first. Any adding and subtracting that we're allowed to do, any multiplying and dividing that we're allowed to do before, so we don't have to separate into an addition unnecessarily. Sometimes we have to. So let's take a look at a more complicated example. 4 is equal to 7 to the exponent 2x plus 1. So I have that exponent. I need to log both sides. Now I have that exponent, so I can bring it down in front. So we have log 4 equals 2x plus 1 log 7. Now remember, I can distribute a log into a binomial, but I can absolutely not distribute into a log. So we have log 4 equals 2x log 7 plus 1 log 7, and that 1 is unnecessary. So now I want to get everything with x on one side and get everything without x on the other. So I can simply subtract log 7 from both sides. So we have log 4 minus log 7 equals 2x log 7. So remembering, adding and subtracting to both sides, I'm not going to actually write I'm subtracting log 7 from both sides. I'm just going to say I'm going to do it and show where it shows up. So then on the right hand side, I'm going to factor out an x. So the left hand side stays as is. I'll factor out the x. I'm left with 2 log 7. And then I can simply divide both sides by 2 log 7. And that is my answer. In the notes, I've typed into the graphing calculator to make sure that it's correct. Keep in mind, there are all sorts of different ways that we can work on these. If, for example, I wanted to have changed it to exponential form right in the beginning and go start with the question and change. So I know that I have log, and remember the base of the exponent is the base of the logarithm, of 4 equals, and remember the exponent is the answer to the logarithm. Well, then I can simply just subtract 1 from both sides. And then I can simply divide both sides by 2. Therefore, x equals log base 7, 4 minus 1 all over 2. So that looks like a much simpler solution. Why wouldn't we just change to exponential form all the time? Well, all sorts of reasons. This process is going to be very valuable for doing more complicated questions that we can't just change to exponential form. Also, changing from exponential form to log form is a very difficult process, whereby logging both sides, bringing your exponent down in front, distributing, removing greatest common factor, and dividing are actually a little bit simpler. But you're going to see in the next question, we absolutely cannot turn it to exponential form. Sorry, from exponential form to log form. So we actually have to do all these processes. So I'm building up those skills, and now we're ready to do more complicated questions. Okay, so the next example in the notes is 2 to the exponent 2x minus 5 equals 9 to the exponent x plus 2. So remembering, if I want to solve for these variable exponents, I need to log both sides. Log 2x minus 5 equals log 9x plus 2. Now I can bring my exponents down in front, and I'm going to do that with brackets. 2x minus 5 log 2 equals x plus 2 log 9. And we should really be able to skip this middle step completely to be able to log both sides and bring our exponents down in front in the same step. It's going to be extremely valuable, way less writing on the page. Now we will distribute on both sides. So we have 2x log 2 minus 5 log 2 equals x log 9 plus 2 log 9. Now we want to get everything with x on one side, so we're going to get these two terms on one side, and then we want to get everything without x on the other. So if I subtract this term from both sides, I get 2x log 2 minus x log 9. And if I add this term to both sides, it's equal to 2 log 9 plus 5 log 2. Now I need to factor out an x. So we have x open bracket. So if I take this x out, I'm left with whatever I'm left with. 2 log 2 minus log 9 equals the right-hand side. And as I've done before, I'm simply going to divide both sides by exactly this thing. And I'm just going to write down where it shows up. So it's going to show up right below here. 2 log 2 minus log 9. Therefore, x equals this. 2 log 9 plus 5 log 2 all over 2 log 2 minus log 9. Now remember, if you type this into the calculator for a decimal answer on a test or whichever, brackets are on the top, brackets are on the bottom, then you can do your division. And that is our exact value. A lot more complicated, impossible to turn from exponential form to log form usefully. Okay. So let's see an interesting version. 6 times 3 to the x equals 14 to the 2x minus 5. So for example, can we divide both sides by 6? Well, absolutely not. 14 has an exponent. And BEDMAS tells us to do exponents before multiplication and addition. So if we can't do that exponent, we absolutely can't do the division by 6. And then another question may be, can we multiply this 6 by this 3 and call it 18 to the x? Well, for the same reason, 3 has an exponent of x. BEDMAS says we have to do exponents before multiplication. So again, we absolutely cannot do that multiplication. So we have variable exponents. It will be very helpful to log both sides. Now on the left-hand side, we have a multiplication, which means I have to separate it into an addition. So we have log 6 plus log 3 to the x equals log 14 to the 2x minus 5. Now I'm allowed to bring my exponents down in front, because before I wasn't. I could absolutely not bring the x down before because it didn't apply to the 6. So if I bring my exponents down in front, remember to use brackets. Then I can distribute this log into this. So I'm going to leave the left-hand side, log 6 plus x log 3 equals distribute. So we have 2x log 14 minus 5 log 14. Now I'm going to get everything with x on one side, and I'm going to get everything without x on the other. So I'm going to get my x's onto the left side this time, arbitrarily. X log 3 minus 2x log 14. And then I'm going to leave this on this side, and I'll be subtracting log 6 from both sides. Now notice I have two negative logs on the right. I probably shouldn't have done it in that order, but we're not going to get too concerned with that. On the left-hand side, I have an x, and I can factor out that x. So x open bracket, whatever's left, equals the right-hand side. And now I'm simply going to divide both sides by those brackets attached to the x. And that is what x is equal to. Remembering, you can type it in the calculator to figure out what the decimal is. But really keep in mind, lots of the times, if I have 2a equals 4, I want to divide both sides by 2, I simply cross it off and put it below the other side. Be really good with these basic skills, because more and more teachers are going to do stuff like divide both sides by some complicated looking thing, and it shows up on the other side on the bottom, and we wonder why. Well, that's basically because of our basic algebra rules to both sides, what to do to both sides, where things show up. So be really careful with those methods. And yeah, another good example of logging both sides. So on our formula sheet, rule number 7 says b to the exponent log base b of x is equal to x. And the English sentence says if you have the same base of the logarithm as the exponent, the answer is this thing. So is that true? Well, let's find out. Let's log both sides and see what we get. So if we log the left-hand side and we log the right-hand side, well, we have an exponent that we can now bring down in front. So I'm going to bring that exponent down in front. Now, this logarithm, I can change bases, which is log x over log b times log b equals log x. And I have log b on the top and the bottom, therefore log x equals log x. Therefore we know this is correct, therefore we know this is correct. We are going to use this rule in coordination with other rules to help solve logarithmic equations. We may need to combine different rules and then decide. We may use rule 3, then 5, then 2, or 6, then 1, then 8. As long as we don't break any of the rules, we'll be able to help solving these log equations.